Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
This is SpaceTime, Series 24, Episode 22. Coming up on SpaceTime, new observations of Cygnus X1, which are challenging science's understanding of black holes. A turning point in Earth's history 42,000 years ago. And growing doubts about the existence of Planet 9. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations of Cygnus X1, the first black hole ever detected, have led astronomers to question what they know about the universe's most mysterious objects. The findings, reported in the journal Science, suggest that Cygnus X1 contains the most massive stellar mass black hole ever detected without the use of gravitational waves. Located around 6,100 light-years away, Cygnus X1 is one of the closest black holes to Earth. It was discovered in 1964 when a pair of Geiger counters were carried aboard a suborbital rocket launched from the White Sands Missile Range in New Mexico. It achieved notoriety in 1975 when Stephen Hawking bet fellow cosmologist Kip Thorne a subscription to Penthouse magazine for Thorne against 4-year subscription to Private Eye magazine for Hawking that Cygnus X1 would not turn out to be a black hole. Hawking lost the bet and finally conceded in 1990. The new research uses the Very Long Baseline Array, a collection of radio telescopes spread across the United States, forming a continent-sized interferometer. The study's lead author, Professor James Miller-Jones from Curtin University and the International Center for Radio Astronomy Research, says the new Cygnus X1 observations use parallax. It's the same principle as holding your thumb out in front of your face and then viewing it with one eye at a time. You'll notice that your finger appears to jump from one place to another, especially compared to background objects. And the same thing works on a stellar scale. Viewing the same object from different locations as the Earth orbits the Sun allows astronomers to calculate distance by measuring how far the object appears to move relative to background stars. Miller-Jones and colleagues observed the full orbit of the Cygnus X1 black hole over 6 days and then compared the data with observations taken of the same system using the same radio telescope array a decade ago. The new, more accurate measurements show the system is further away than previously thought and that the black hole is significantly more massive. In fact, the new observations suggest the black hole is so massive it actually challenges how astronomers thought they formed. Stars lose mass throughout their lifetimes to the surrounding environment through stellar winds, just like the Sun's solar wind, which is blowing plasma and matter away from the Sun. But to make a black hole as heavy as Cygnus X1, scientists would need to dial down the amount of mass that a bright star loses during its lifetime. The stellar mass black hole in Cygnus X1 began life as a spectral type O blue star, originally thought to be about 60 times the mass of the Sun. The star finally burnt through its fuel supply and collapsed into a black hole tens of thousands of years ago. It's in a binary system with a blue supergiant variable star companion, designated as HDE 226868. The pair orbit each other every 5.5 Earth days, at a distance just 1/5 that between the Earth and the Sun. The new observations suggest the black hole could have up to 50% more mass than previously estimated. The updated measurements of the black hole's mass and distance from Earth also suggest that Cygnus X1 is spinning incredibly quickly, In fact, very close to the speed of light and much faster than any other black hole ever found. Miller-Jones says the start of construction next year of what will be the world's largest radio telescope, the Square Kilometre Array, will shine a new light on the secrets of black holes and provide more information about the mysteries of Cygnus X1.
Cygnus X1 is the first black hole that was ever confirmed. It's a binary star system containing of a black hole in orbit with a massive supergiant companion star. The two stars are separated by about a quarter of the distance from the Sun, and they orbit each other once every 5.6 days. The black hole is feeding from the gas that's expelled in the wind of the massive star. It's a bit like our solar wind, only much, much stronger. And some of those gas particles in the wind are pulled in towards the black hole, and they spiral in towards its, like water spiraling in down a plug hole, if you like. And they get very, very hot, and they emit X-rays. And those X-rays are how the system was first detected by suborbital rocket flights back in the 1960s, when they put Geiger counters on these rockets and detected X-rays coming from a source in the constellation of Cygnus. So in the early 1970s, people looked at the system and figured out that it was likely to contain a black hole, and it's been subject to a lot of research over the last several decades. And our recent work has just provided an update to the mass of the black hole in the system, which makes it the most massive stellar mass black hole ever detected in ordinary light, that is without the use of gravitational waves, and the most massive stellar mass black hole that we know of in our Milky Way galaxy. So our observations were taken with radio telescopes. So the Very Long Baseline Array is an array of 10 radio telescopes spaced across the US from Hawaii to the Virgin Islands. And with the precision that we can achieve with these telescopes, we could localize an object on the moon to within 10 centimeters. So what we did was to measure the position of the radio emission coming from the system. So this is due to the radio waves given off by the relativistic jets being launched from close to the black hole. So they track the motion of the black hole in its orbit. So the black hole is orbiting with its companion star, and that orbit takes 5.6 days. And so we had a 6-day observational campaign with this telescope back in 2016. And we were able to actually, for the first time, map out the motion of the black hole in its orbit. So that was a large part of enabling this result. But what we then did was to combine our new data with archival data taken back in 2009, 2010 that sampled the Earth's orbit around the Sun. And by doing that, we're seeing Cygnus X1 from different vantage points. And so it appeared to shift back and forth slightly against very distant galaxies that don't appear to move. So this is the effect called parallax. If you hold your finger up at arm's length and close one eye and then the other, you'll see your finger appears to move relative to the background. Well, we were doing exactly the same thing, but instead of looking with one eye and then the other, it's looking from opposite sides of the Earth's orbit. And that is able to determine the distance to the system according to how much it moves. We can figure out just using simple trigonometry how far away it is. The previous data that were taken a decade or so ago enabled them to measure a distance to Cygnus X1. What our data showed is that the effect of the black hole's orbit on the sky has a more significant impact on this measured apparent motion of the black hole. So there are two things going on. The first one is the black hole's moving in its orbit. And the other thing is that as the black hole goes behind its companion star, we see it through more of this strong stellar wind that the star is giving off. And that causes apparent shifts in the position of the radio emission that we detect. And so taking account of these orbital effects allowed us to calculate a more accurate distance to Cygnus X1. With an updated distance, we were able to update our estimate of the black hole mass because the intrinsic brightness of the star depends on how far away it is. We measure an apparent brightness. If we know how far away it is, we can calculate the intrinsic brightness of that star, which we can use to basically model the brightness variations and the velocity variations of the star as it goes around its orbit. And from that, we could figure out the mass of the black hole. And that came out as 21 times the mass of the Sun, which was significantly more massive than had been previously believed, and also than our theory suggested should be possible.
And that must change the way science sees stellar mass black holes.
That's right. So this measurement is challenging our theories as to how we make black holes. So black holes are forming from the deaths of the most massive stars. A massive star will live only a few million years. Stars are spending their lives burning nuclear fuel to prop themselves up against gravity, which is trying to pull them all together. And when they run out of nuclear fuel, gravity takes over and the star collapses. Now, these massive stars drive very strong stellar winds. As I say, these are much like the solar wind comes from our sun, but much, much stronger. And in certain phases of the star's lifetime, it can be losing as much as an Earth's mass of gas every day. And so over the course of their lifetime, before they get to the point where they collapse into a black hole, these very massive stars will lose a large amount of their initial mass. So we think that the progenitor of the black hole, so the star that eventually collapsed into the black hole in Cygnus X1, it probably started off its life somewhere between 55 and 75 times the mass of our sun. And yet by the end of its life, it had got down to only just about 20 times the mass of the sun, whereupon we think it collapsed directly into a black hole. So our previous theories of how massive stars evolved suggested that in a Milky Way-like environment where there are lots of heavy metals, things like iron, in the atmosphere of the star, the strength of the stellar winds that they should be blowing off ought to have restricted the mass of the ultimate black holes that they eventually create to no more than about 15 times the mass of the sun. If you reduce the amount of heavy element in the gas that makes up the star, the strength of the stellar winds goes down, and so you can make slightly more massive black holes if you have a less enriched set of gas from which the original stars formed. But in a Milky Way-like environment where Cygnus X1 is located, we didn't think we should be able to produce a black hole with a mass higher than about 15 times the mass of the sun. So finding something that's 21 solar masses was a bit of a surprise, and we had to recalibrate our models of how much material these massive stars lose in winds over their lifetimes. And so that was very exciting, touching on a lot of different areas of astronomy that are impacted by the lives of massive stars.
How can one differentiate between the amount of mass the black hole has from its formation compared to how much it might have as a result of other infalling material, such as that coming from the companion star? Or is that something you just have to estimate?
So the nice thing about Cygnus X1 is that it's in a system with a very massive companion star. So we know that the system has to be young because we know that its companion star cannot have lived for more than 4 or 5 million years. Just massive stars, they live much faster because they have to burn fuel at a much higher rate to prop themselves up against gravity. And therefore, over the entire lifetime of the system, the black hole could not have increased its mass by accreting gas from the companion to any significant extent. And therefore, the mass the black hole currently has should be relatively close to the mass with which it was formed. Most of the other systems we know of in our galaxy that contain black holes, they have much lower mass, much older companion stars. And that means that the systems themselves can be significantly older, and the black holes can have increased their mass significantly over their lifetime. But in the case of Cygnus S1, because the companion star is so massive, it cannot have lived for more than a few million years, which means the black hole cannot have increased its mass significantly since it was born.
So we know what it's been eating, so consequently we know how much it's eaten, and we know how big it could have gotten and couldn't have gotten that much bigger.
Exactly, yeah.
An important question, any bets going on this particular discovery?
Well, Stephen Hawking and Kip Thorne certainly had their famous bet on this particular system. I did not have any wagers riding on this particular discovery, although since the Hawking and Thorne bet has gained a bit more publicity, my co-authors have suggested that perhaps we should take up something on future discoveries.
Private Eye magazine?
We'll have to see. We'll have to see.
That's Professor James Miller-Jones from Curtin University and the International Centre for Radio Astronomy Research. And this is Space Time. I'm Stuart Gary. Still to come, an ancient relic pointing to a turning point in Earth's history 42,000 years ago. And there are now growing doubts about the existence of Planet 9. All that and more still to come on Space Time.
OTR drivers, keep your business rolling and your finances traveling toward a positive financial future. Make TaxesForTruckers.com your partner to handle the money side of things. Started by the daughter of a long-haul driver, TaxesForTruckers.com understands your business and can help you pay less taxes, keep your books, and track your finances, keeping you on the road towards your financial goals. And they're local in the Midwest, but available nationwide. Get started at TaxesForTruckers.com. That's taxes, the number 4, truckers.com.
A new study has found that a temporary breakdown in Earth's magnetic field 42,000 years ago triggered major climatic shifts that led to global environmental change and mass extinctions. While scientists already knew that the Earth's magnetic poles temporarily flipped around 41 to 42,000 years ago, an event known as the Landschaft's excursion, they didn't know exactly how it impacted life on Earth, if at all. The new findings, reported in the journal Science, suggest that there was a dramatic turning point in Earth's history, triggered by the reversal of Earth's magnetic poles and also changing solar wind conditions, which caused massive electrical storms, widespread auroral activity, and a flood of cosmic radiation. Researchers from the University of New South Wales and the South Australian Museum were able to determine exactly when the event occurred by studying ancient New Zealand kauri trees, which had been preserved in sediment for over 40,000 years. Scientists used these ancient trees to measure and date the spike in atmospheric radiocarbon levels caused by the collapse of Earth's magnetic field. They found the magnetic field weakened to just 28% of its present-day strength for up to 800 years during the period of the magnetic flip. But the new findings also suggest that the most dramatic effect actually happened in the lead-up to the reversal, when the magnetic poles were migrating across the Earth. The authors say their data shows that Earth's magnetic field crashed to between 0 and 6% of its usual strength. Now, what that means is that essentially, for some period of time, Earth had no magnetic field at all to shield the planet from solar and cosmic radiation. During this magnetic field breakdown, the Sun experienced several so-called grand solar minima. These are long periods of quiet solar activity. Now, even though a grand solar minima meant less activity on the Sun's surface, the weakening of the Earth's protective magnetic field still resulted in higher levels of solar radiation from the Sun, as well as higher levels of cosmic rays from deep space getting in as well. And these would have penetrated the atmosphere, reaching right down to the Earth's surface. Now, the authors claim that as this was happening 42,000 years ago, megafauna across mainland Australia and Tasmania went through simultaneous extinctions. It also coincides with the growth of ice sheets and glaciers over North America and large shifts in major wind belts and tropical storm systems. The authors say the unfiltered radiation from space would have ripped apart air particles in the Earth's atmosphere, separating electrons and emitting light, a process called ionization. They say the ionized air then fried the ozone layer, dramatically increasing ultraviolet radiation and triggering a ripple of climate change across the globe. It also meant dazzling auroral light shows would have become frequent events. Northern and southern lights, the aurora borealis and aurora australis, which are caused by solar winds hitting the Earth's atmosphere and usually confined to the polar and higher latitude regions, would have been widespread during the breakdown of Earth's magnetic field. And all this ionized air, which is a great conductor of electricity, would have increased the frequency of electrical storms. The authors suggest that these storms must have seemed like the end of days, causing early humans to seek more shelter. And they speculate that this sharp increase in ultraviolet radiation levels, especially during solar flares, would have suddenly made caves very valuable shelters. In fact, the common cave art motif of red ochre handprints may well signal that it was being used as a sunscreen, a technique still used by some groups today. This is SpaceTime. Still to come, growing doubts about the existence of the long-sought-after Planet 9. And later in the Science Report, a new study says there are big advantages in delaying the second jab of the Oxford AstraZeneca COVID-19 vaccine. All that and much more still to come on SpaceTime. Hopes of discovering a ninth planet in our solar system are fading, with a new study suggesting earlier observations of unique clustering of Trans Neptuneian objects may have been caused by bias in the way these objects are observed. Trans Neptuneian objects is a catch-all term used to describe the comets, icy bodies, frozen debris and dwarf planets circling the Sun out beyond the orbit of Neptune. These include all the objects in the Kuiper Belt, as well as those in the scattered disk and the synoids, but strangely, not objects in the Oort cloud. Back in 2016, scientists from the California Institute of Technology noticed unusual gravitational perturbations in the orbits of 13 Kuiper Belt objects. These perturbations, or clusterings, are thought to have been caused by interactions with an as-yet undiscovered massive planet. This long-hypothesized Planet X, or Planet 9, would have been up to 4 times the size of the Earth, with around 9 times Earth's mass, and on a highly elliptical orbit around the Sun, estimated to last around 15,000 years. The authors of the original study also suggested that the possibility of the clustering they observed being a coincidence was just 0.007%. Now, if it exists, the mysterious Planet X could be an interstellar rogue planet captured by the Sun's gravitational pull. Another possibility is that it was stolen by the Sun's gravity from another star system. And there are several models of planetary migration within the early solar system which suggest that as Jupiter and Saturn migrated out to their current orbits, their gravitational perturbations caused Neptune and Uranus, the two ice giants, to move further outwards, in the process swapping orbital positions and flinging a third ice giant out into the Kuiper Belt or possibly beyond into interstellar space. However, this new report on the pre-press physics website archive.org claims the apparent clustering was more likely due to a natural bias inherited in the way that trans Neptunian objects were being observed. The authors claim that because they're so far away, these objects can only really be seen when they're closest to the Sun, and that forces astronomers to focus on just one specific patch of the sky on a certain day. And that very process introduces bias. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Scientists have found that a 3-month interval between the initial and booster injections of the Oxford AstraZeneca COVID-19 vaccine seems to be more effective than the currently prescribed 6-week interval. A report in the Lancet Medical Journal says a study of over 17,000 participants found a 3-month interval to be 81% effective in preventing symptomatic COVID-19 cases, compared to 55% for those receiving their 2 doses separated by a 6-week interval. The analysis also showed no hospitalizations or deaths among those receiving the vaccine for up to 22 days after the first dose. Over 2.5 million people have now died from the COVID-19 virus, and another 114 million have been infected with the disease since the virus first emerged from Wuhan, China, and spread around the world. Scientists have completed phase 3 trials of a new drug which could be a real game changer in the fight to treat obesity. A report in the New England Journal of Medicine claims trials involving almost 2,000 people found that the drug semaglutide reduced body mass by at least 10% in 75% of participants, and 20% of those who took part lost an incredible 35% of their body mass. Those taking part in the trial were given a weekly 2.4 milligram injection of either semaglutide or a placebo for 68 weeks. Researchers say the average participant lost 15.3 kilos. The drug, which is already approved at a lower dose of 1 milligram for type 2 diabetes, works by hijacking the body's appetite-regulating system in the brain, leading to reduced hunger and calorie intake. It works by mimicking the human glucagon-like peptide 1 hormone, which is released in the bloodstream after meals to make you feel full. Scientists have recovered the world's oldest samples of DNA from 2 specimens of mammoths that walked the Earth more than 1 million years ago. The oldest previously sequenced DNA dates back to between 560 and 780,000 years ago. A report in the journal Nature claims paleontologists discovered the mammoth remains in the Siberian northeast. Of the 3 mammoths found, one is approximately 1.65 million years old, and another lived around 1.34 million years ago. The 2 behemoths came from a line which eventually gave rise to the woolly mammoth. A bit of great news if, like me, you need that cup of coffee in the morning and then you have a few more as the day wears on. 3 new studies have shown that drinking more coffee is associated with a reduced risk of heart failure. The results, reported in the journal Circulation, are based on findings from the Framingham Heart Study, the Cardiovascular Heart Study, and the Atherosclerosis Risk in Community Study. Researchers used machine learning to examine data from the original cohorts in the Framingham study and reinforced it against data from the other 2 studies to help confirm their findings. The studies, involving some 21,000 participants, included at least 10 years of follow-up. The authors found that in all 3 studies, people who reported drinking 1 or more cups of caffeinated coffee a day had an associated decreased long-term risk of heart failure. The Framingham and cardiovascular heart studies found the risk of heart failure over the course of decades decreased by 5 to 12% per cup of coffee per day, compared to those who didn't drink coffee. In the atherosclerosis study, the risk of heart failure didn't change between 0 and 1 cups of coffee a day. However, it was about 30% lower in people who drank at least 2 cups a day. Interestingly, the Framingham study also showed that drinking decaffeinated coffee seemed to have the opposite effect, significantly increasing your risk of heart failure. The United Kingdom Professional Standards Authority has suspended the Society of Homeopaths. The British government watchdog, which regulates healthcare, found that the Society of Homeopaths' actions led to risks to the public from homeopathy being offered as an alternative treatment for serious conditions such as depression, arthritis, and autoimmune conditions that require medical supervision. Tim Mendham from Australian Skeptics says the emergency review was prompted by the Society of Homeopaths appointing an anti-vaxxer to a position overseeing professional standards.
Yeah, well, in the UK, the Professional Standards Authority, or PSA, is the body that accredits medical associations and certainly checks out their claims in advertising and promotion and that sort of thing. And they've decided that the Society of Homeopaths should have their accreditation suspended, basically because what they found out after a lot of examples being put forward was they did not prioritise public protection over their professional interests. In other words, they are more about pushing the, I'm not going to use the term doctor because they're not, the practitioners of homeopathy, the homeopaths, rather than the public and the patients they're supposedly treating. We know that homeopathy has nil scientific support for it. Nonetheless, they still are out there trading, taking people's money. But what was specifically of concern, the UK Good Thinking Society, which is like a skeptics group over there, has been campaigning against homeopathy for some time, especially that it has had some funding from the National Health System and various things like that. Most of those avenues for the homeopathic funding has been closed because of the work of Good Thinking. But there's the various areas that they keep looking at, including the promotion of a particular therapy to cure autism, and there's a strong anti-vaccine thread that runs through a lot of the people who are homeopaths. And that is what actually caused the Professional Standards Authority to really take notice, this last thing, because they appointed a person who was listed as Professional Standards and Safeguarding Lead, who was an anti-vaxxer. And this is when they talk about not looking after patients' needs and rights. And this person was repeatedly sharing anti-vaccine misinformation, which I think most anti-vaccine information is misinformation. And despite these conditions imposed upon the Society of Homeopaths, because they failed to take action against this, the PSA jumped on them and said, right, your accreditation is gone. Now it's suspended, so it's not necessarily sort of gone forever, but this is a big kick or hit to the homeopathic industry in the UK, which has already been taking a hit across Europe, thanks to the Australian National Health and Medical Research Council, which did a big study of homeopathy a few years ago and found that there's, bugger all to support it. There's evidence in there, no evidence whatsoever to support it. And that received a lot of publicity in Europe where homeopathy started.
For our listeners who don't know what homeopathy is, that's magic water, isn't it?
It is, absolutely, yeah. And it's a system where people think it's often herbal medicine, but it's not. It's based on the original idea that like cures like. So if you have lead poisoning, you take a bit of lead, which doesn't seem to work very well. If you have trouble sleeping because of coffee, etc., then you have a little bit of coffee. A tincture of coffee will actually help you to sleep. It's pre-science, pre-evidence-based medicine. It's a couple hundred years old, this system, and they haven't updated it really. But the trouble is, what you do is when you get this tincture of a substance which is going to fix your problems, you dilute it, and you dilute it, and you dilute it in a system called succussion. I hope I pronounced that correctly. You put one drop in 100, shake it up, bang it on something. You often bang it on a leather book or something like that. Take one drop of that, put it in another 100 drops and bang it and shake it and that sort of thing, and then take one drop of that and put it in another 100 drops and shake it and do that sort of stuff. You do that up to 30 times, and basically there's nothing left of the original material. This is then served up in a bottle as a liquid or as little sugar pills and sold as specific to your needs. Obviously, how specific it's going to be in a health food shop, I don't know. But there's all sorts of things. Like if you feel barriers in your life, this is a real product. If you feel barriers in your life, that there are sort of things restricting you, you should have a product which draws from the Berlin Wall. Someone has gone and got a bit of the Berlin Wall, smashed it up into little pieces in the mortar and pestle, and taken a little bit of it and put it in water and put that in water and put that in water and put that in water and water, and you keep going. And the trouble is, if there's nothing left of it to actually work, they justify that by saying that this water substance, if it is water, has a memory, and it keeps a memory of that original substance, even though the substance is not there anymore. The theory of like cures like doesn't work. The system of dilution takes away any possibility that there's anything there to do the job, to treat you. Scientific in quote, tests have been inconclusive or poor, which is what the National Health and Medical Research Council found, and that it's no better than placebo, including, as stated by some homeopaths, who are now persona non grata in the homeopathic community.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.